All right, right on time. Welcome everyone, and just do a little bit of an overview. We're here now. Today we are going to look at lesson 6. We focused on lesson 5 on Wednesday. There was a few items that we didn't get to, but they'll be incorporated into lesson 6 today. So we'll just do that. And then on Wednesday, we have the opportunity to kind of have our in-class tutored math for both 5 and 6 together. And then Monday, looking ahead, there is a review in Canvas that you can do for the midterm. And then we'll go over that on Monday, work some problems together, all that kind of stuff. And then we'll have our midterm exam on Wednesday next week. I should have access to the exam by Wednesday, and I'll update you on how many questions and everything. But it is 30% of your grade. The final's 30% of your grade. So that's that.
For the midterm, do we have to stay in class till everyone's finished?
No. So you're here, you've got the full class period to take it, but when you're done, you can turn it in and head on out. Okay, so we're going to take a look. I updated this morning, and it's available to you now. There's a link in lesson 6, which covers chapter 5.1. So what we're going to talk about today specifically are quadratics, and their graphs are called parabolas. So we're going to look at those characteristics of the graph. We will be able to, as we know, there's always a minimum or a maximum value depending upon how it opens. And remember, quadratics always have sort of this U shape, either U shape up or U shape down. And then we'll solve some problems involving quadratics that take advantage of that minimum point. So here are the points of interest, or the characteristics of interest from a quadratic. And remember, it's anything that has a form of ax squared plus bx plus c, where a, b, and c are numbers. And this is some kind of a function from the y value. So one of the things we get interested in are x-intercepts, and we found that by factoring or using the quadratic formula, right? X equals minus b over 2a plus or minus, and I'm writing it in a slightly different form, but I'm just splitting the fraction up, b squared minus 4ac over 2a. So you could also write it as one fraction because they do have a common denominator. But I also wanted you to see that this part we're going to talk about today is the x-coordinate of the vertex. And then we see that, so that's how we're going to find the vertex, is just minus b over 2a. And then you add and subtract two numbers, and that's how you get these x-intercepts. It's basically the x-coordinate of the vertex added and subtracted, and we get the x-intercepts. Okay. Along with the vertex, x-intercepts, y-intercept sometimes plays an important role because that's the starting value. Sort of when x is 0, that's the value there. So sometimes that's important. And then the axis of symmetry is what cuts the parabola in half, and it's tied to the vertex. Okay, it's the x-coordinate of the vertex. Whatever that is, it's going to be this, x equals minus b over 2a. So that's how we get the x-coordinate. So it's U-shaped parabola. There is this vertex, which is also a turning point. So we notice that the graph goes from decreasing to increasing. So that's what turns, changes there. If it opens upward, notice the vertex will be a minimum value. And if it opens the other way, so opens downward, then we have a maximum value. So the vertex is a very important point, And again, we can, once we have the formula, we can get the x-coordinate from the vertex by just looking at this part of the quadratic formula. And this is stating, yes, if it opens downward, then we've got a maximum value. There's symmetry to every parabola, which means that there's a place where you could cut it in half and the left side matches the right side. That's the axis of symmetry, and it's always going to be a vertical line at x equals minus b over 2a. So that gives us the x-coordinate of the vertex. It also gives us the axis of symmetry. So a lot going together, but it'll also connect us with a lot of the things that we were talking about earlier. So parts of the things we're going to work with, we'll be given a quadratic, and then we need to, from the graph, try to come up with all these characteristics. So I'll change colors here. We want to find the vertex, the axis of symmetry, the zeros, and the y-intercept. Incidentally, when they call them zeros, these are also called x-intercepts. So the zero it's referring to is that y is equal to 0. Okay. So the vertex we find visually right here, and that's going to be the point -1, 8. Axis of symmetry, that's what goes through the vertex, so it's a vertical line that cuts the vertex in half vertically, and that's going to have an equation of x equals -1. Okay. The zeros.
So the axis of symmetry is -1?
X equals -1. So yeah, the axis of symmetry, an axis is a line. It's always got to have an equation. So axis of symmetry, x equals -1. And that's a vertical line there at -1 in this case. The zeros are points where the parabola crosses the x-axis. So those are generally ordered pairs. They're the place where x has a value, but y is always 0. Okay, so one of the points we can see there is -3, 0. So the y-coordinate is 0. And the other one would be +1, 0. Okay, so those are two zeros or two x-intercepts. Okay, and what we're going to also see is we work backwards. Once we have these pieces of information, we'll actually be able to come up with the equation for the quadratic formula, or for the quadratic equation in two different forms. And then the last one is the y-intercept. That's where it crosses the y-axis, and we see that here. That's where x equals 0 and y is a value. So in this case, x is 0, y is 6. And you know, with this information now, there's a couple different ways we can come up with the formula, and we're going to deal with those individually. We looked at doing it by factoring. So this gives us, remember, x equals -3, x equals 1. So we could come up with the factor. What's that? Right. So x equals -3. Or I think of, you solve for 0, so you add 3 to both sides, you get x plus 3 equals 0. So this would be the factor that we use. Over here, x equals 1. Subtract 1 from both sides, you get x minus 1 equals 0. So this would be the other factor. So we're kind of getting to where we know that this quadratic could be written as x plus 3, x minus 3, or sorry, x minus 1. And then, I guess, give myself a little bit more room. That comes from the zeros, but remember there could be something that's multiplying by it, so we would then find a point to figure out what that factor is. And we're going to do this on several different examples, but this example was primarily if you have a quadratic graph, how do you get all these values? You have to pick them off the graph. Any questions or doing okay? Okay. And just those who have just come in, I have a bad toothache, so I was able to get an emergency appointment to see a new dentist. So I've got to get out of here at about 11:15. So we got about a half hour. So I'm going to work through it. Wednesday is again going to be an open work day. And you're welcome to stay here and work on things if you'd like. I just have to get on the road to get to my dentist and get this taken care of before I pass out or something. And again, I don't know whether it could be from sinuses as well. So, but it's no fun. Okay. So, what happened here? My cursor went out. Okay, now it looks like, okay, we're back. Okay, so one of the things we talked about is that the vertex of any quadratic comes from the quadratic formula. Let's see if it's still there. No, it got erased. I thought so. So remember, the quadratic formula is minus b over 2a, and I'm going to separate this plus or minus square root of b squared minus 4ac over 2a. Common denominator, usually we just list this as one fraction with the plus or minus up in the top. But I wanted you to see it in this way, is that this part gives us the vertex. We add this value to it and we subtract it. So this is kind of the center of the vertex, or sorry, center of the parabola, which we call the vertex. And they use the letter H to label that. To find the y-coordinate, we then take that value, that x-coordinate, we plug it into the function, maybe like this one, and that will give us the y-coordinate. I don't know why they have this extra a here. I think that's not correct. Okay, so we'll plug it back in. The other thing is there's a special form for a quadratic that's called the vertex form, and we're going to see how we can use what's called completing the square to get this particular form. If we have the quadratic, instead of ax squared plus bx plus c, we have it as a times the parentheses x minus h squared plus k, then h is the x-coordinate and k is the y-coordinate for the vertex. Now they're calling it standard form here. I've also seen it called vertex form because, again, it's the standard. It gives you the vertex. The general form is the one we typically use. But again, if you graph either one of these, you'll get the same graph if the same numbers that are there. Okay, so let's see. We're given a graph, and now this is where we're asked to write the equation of the quadratic function. And they want us to think about what are the transformations that it would go through to go from starting at f of x equals x squared. Remember, that would be a parabola that would go through 0, 0. So this is x squared, something like that. And what we can see is the vertex has been moved, what? Down 1, 2, 3. And then it's been moved to the left 2. And so you can think of, if we started with y equals x squared, from just the transformations alone, we now have inside, to move it 2 to the left, remember, we add 2. Good. And to move it 3 down, we subtract 3. The only thing we're not sure of is that maybe this has been stretched or shrunk somehow. So there could be this value here of a, and it's just some number. We don't know. They use a. It doesn't necessarily mean it's the a from the quadratic equation or but it's just a voice. Well, how are we going to find that? Well, what we need is we need any point on this graph. And again, we could choose this point here. I think this one would be a nice one because it's got x equals 0. So if we ever get a point where we can have like x equals 0, that's the one I would use. But we could use any one. But this point here is 0, -1, which is the y-intercept. What we need is we need a point other than the vertex. Because if we plug in the vertex, we get everything 0, and that doesn't help. So what I'm going to do is I'm going to plug in x equals 0, y equals -1, and we will solve for a. So that's going to give us -1 equals 0 plus 2 is 2. 2 squared is 4. So I'm going to have a times 4. I'm going to write that as 4a minus 3. We're going to add 3 to both sides. That's going to give us 2. Divide both sides by 4. We can still see all this. Okay, good. And so if you divide both sides by 4, you're going to get that a equals, cancels, divided by 4. 2 divided by 4 is 1/2. So that tells us we actually know the equation. We could graph this by putting the equation in. I'll change this to blue. Y equals 1/2 x plus 2 squared minus 3. So if we know the vertex and one other point, we can graph. We can come up with the formula for the quadratic. Any questions on that one?
Do you always use the y-intercept?
The y-intercept's the easiest one because that gives an x equals 0. You don't have to. We could have used this point over here, which is -4, -1, but notice we would have had -4 here. Yeah, it's just.
Is there any case where you wouldn't be able to use the y-intercept?
Only if the y-intercept is also the vertex, because you need a point other than the vertex. So as long as the vertex is off to the side, you can always use the y-intercept, and that would be my preferred point to use, as long as it's a good point. Sometimes it's like in between. But this one, if you can get a nice solid point, crossing right here, I know exactly where it is. But yeah, if it was crossing in the middle here, I wouldn't use the y-intercept. I'd use some point that I could find where it's going, right through the crosshairs. And we can use any one that is not the vertex. Okay. So then we're asked to put this into vertex form. This is where we're going to use something called completing the square. And the reason we do this is if we have something, say, like x plus 8 squared, this is what we're trying to do. If you FOIL this out, let's see what we get. We get x squared, we get 8x, we get 8x.
Unknown caller.
Turn that off. We get 8x, and then 8 times 8, we get 64. So we get x squared plus 16x plus 64. Or in a way, this is 16 is 2 times 8, 64 is 8 squared. And the way, so we see we've got x squared plus 16. So what's going to happen is to complete the square, we need 64, not 63. But it doesn't matter what's here. What we're going to do is we're going to put this plus 63 down here. What we're going to do is we're going to add the number that we need. And I'll show you that we will always get the right value if we take the middle number here, which is 6, the number in front of the x. If we divide it in 2, and we square it. But can we just add a number to an equation, to an expression, without changing it? No. So it's going to change it, so what we do, but if we add a number and then subtract a number, what do we really do? That's 0. We can add 0 to anything. So this is the little trick we do is over here, we're going to subtract 16 over 2 squared. This is a little trick. But what we've done is if we group it like this, we have completed the square. And so this is going to factor 16 divided by 2 is 8. It's going to be a perfect square of x plus 8 squared. And I mean, we just did that up here. X squared plus 16x plus 64 factors into x plus 8. If we were to reverse do this, we would get x plus 8. Okay? So just remember, it's completing the square. We'll do it again. But this part becomes x plus 8 squared. Over here, back here, we've got 63. And what's 16 divided by 2 is 8 squared is 64. What's 63 minus 4? Or what's 63 minus 64? Negative 1. We have completed the square. And we have this in vertex form now. Yes.
So the x plus 8 squared minus 1 is equivalent to the original equation?
It is. Yeah, if you were to FOIL this out, so we come over here, what is x plus 8 squared? We did that up here. Well, that's x squared plus 16x plus 64. We just that's this. Minus 1. So we get, it's just putting it into a new form. Okay. Which is good because really we didn't add anything to it. We added 0, but we added 2 different things. We added 1 and we subtracted it at different parts. So it helps us put it into this this form of the equation. And what it does is now we can see what the vertex is. The vertex is going to be, it's always the opposite sign. Remember this transformation? If we've got a plus 8, that means it moved it the other way. But then this one on the outside, the y value is exactly what you think it is. So this is our vertex. And one way we can kind of prove this is what we'll do is we'll go and we'll actually go ahead and graph this original form, and you'll see when we put it, the vertex is going to be at negative 8, 1. Let's keep everything. And I think I closed it. Go ahead and get my graphing calculator. Hopefully it'll open up without having to sign in, save us a little time. Or, yeah, here it comes. Okay. See, what was it? Was x squared plus 16x plus 63. And then when we'll go zoom standard, when we graph it, we see it's at negative 8, negative 1 is our vertex. And if you're not quite sure, we can go to the table. Here at negative 8, it's negative 1. And then you see on both sides of negative 8, you see the y values are both 0. So you see the symmetry going up from that negative 1 is that vertex, that lowest point. You see that on the table here. And you see this symmetry. If I go 3 this way, I got 8. If I go 3 this way, I got 8. So you can see that. So getting it into this form, we could either do it with this form, or we could graph it. Again, you can always just graph it, and that will give you the vertex, and say, okay, let's just put it in vertex form. But there's a few in the homework that are that way. And then you could always change it to the general form by multiplying it out. So here's the steps. Again, most of these I'm not going to read step by step, but they're here for you if you want to pull them up, because there's a link in Canvas that gets you to these slideshows. These are also taken from the textbook, so it's kind of a way of getting there. So if you're given a quadratic function, another way to get the vertex form is we could do completing the square, but that's kind of what we were doing, right? If we have a, b, and c, notice we were taking b, which was the number in front of x, dividing it by 2, and then we can get its y-coordinate as well. So let's take a look here. So this one would be a little harder to complete the square because we don't have 1 in front of the x. But what we can do is we can find the x-coordinate of the vertex. So it will be x equals minus b over 2a. And remember, a is here, b is here, c is there. B would be negative 5, so we're going to have minus negative 5. 2 times a is 3. So our vertex is going to be positive 5, or the x-coordinate of the vertex is positive 5. 2 times 3 is 6. So that is our x-coordinate of the vertex. How do we get the y-coordinate? We plug that number, the x-coordinate, 5, 6, into the quadratic. So that's going to give us 3 times 5/6 squared. Did I get that right? It's not going to be a very nice number, but I guess we'll deal with it. So this is going to give us the y-coordinate of the vertex. 5, 6 squared is going to be 25 over 36 times 3. I think 3 is like 3 over 1. So we'll get some canceling there. This is going to give us 5 times 5, which is 25 over 6 minus 1. 3 goes into 36 12 times. So we end up with 25 divided by 12.
Minus 50 over 12.
Well, this is 25 over. Oh yeah, you could get a common denominator. Could turn it. It's not going to be nice decimals. Yeah, you could say, well, if we got a denominator of 12, we could turn this into 12 by 2 over 2. So we get 25 minus 50 will give us negative 25 over 6 minus 1, which we could rewrite as 6 over 6.
Wouldn't it be negative 25 over 12?
Oh, sorry. Sorry, thank you. I was trying to reduce too quickly. Okay, so this is, 12 times, 2 times 6 is 12. Thank you. 25 minus 50 over 12 gives us this. And so then we're going to subtract 1. And you can always write 1 as any number over itself. So let's go with 12 over 12. So it looks like we end up with negative 37 over 12. Not a very pretty number, as you say. But the vertex then is going to be 5, 6. negative 37ths over 12. And then we could write it in vertex form. Again, I would probably leave this as decimal forms, graph it, and we can find our vertex for most of the things we need to do. Okay, finding domain and range. The domain is what feature of a function? It's the x values. The range are the y values. So the x values we'll see on a quadratic are always, there we go, yeah. It will always be that because we can plug anything into a quadratic. So the domain you just memorize. The range, what we need to do is we need to find the vertex. And again, it's got 2. So with a negative, it's going to open downwards. So we go, our range is going to be from the vertex, the y-coordinate of the vertex down. If we have a positive number in front of the x squared, then it will be from the vertex upwards. So this would be the y-coordinate to negative infinity, or the range is going to be, sorry, that's backwards, right?
Yeah.
Oh, it's the way you think about it, but negative infinity is always the smallest number. Over here, it would be from y up to positive infinity, parentheses there, bracket there. Okay. So we just need to know what the y-coordinate of the vertex is. Again, one of the fastest ways I know to do this is to graph it. Negative x squared plus 4x plus 3. So we'll get good at using our graphing calculators, hopefully. And again, you can use Desmos or you can use an online one to get used to it. But if you've got the TI-84, this is a very good use of it. Then what was it, plus 3? We see our vertex here. One way to find the vertex, we go to second calc, and that's going to be a maximum. And so we need to, with this calculator, make a left bound. We are to the left of the vertex, so I'm going to hit enter. And notice I get sort of a dashed line there. I move it to the right because the question down here is where's the right bound. So I move it to the right of the vertex, and I'm going further than I need to, but I like to go at least to the other side. So notice it's going to now, when I put in a guess, it will look between these 2 points to find the maximum value. I'm just going to hit enter. And it found the maximum. I would round that to 2.7. 2.7. So as I come back here, since it's asking for the range, I say, well, the vertex was 2.7. And so it is going downwards, so it's going to look like this. So the y-coordinate was 7, so my range is going to be from negative infinity, oops, to 7. And 7 is included in the range. So far as that makes sense, domain and range, best way to get it from the graph. Good. Again, we can do the same thing here. This is a little bit easier because it's in vertex form. So domain, it's always going to be for a quadratic negative infinity to infinity. because you can plug in any x value. The range is going to be, so what we look for is what would be the x squared. X squared is going to have a positive 2 as a coefficient. So positive is, think of it as a smile. Smile, positive things make you smile, so it's going to open upward. This is going to be a minimum, and the y-coordinate of the minimum, because we're in vertex form, is 8/11. So it's going to go from 8/11 up to positive infinity. So our range is going to be 8/11 to infinity. So when we have vertex form, we can actually just pick the range right off of there. Without graphing, you could graph it, and you'd see the same thing. Okay. Maximum and minimums come directly from the vertex. So the location of the vertex gives you the location of where the minimum or maximums occur, and the value, the y value, right, gives you the value of either the minimum or the value of the maximum. Okay, so that's the value. This gives you the location. That gives you the value. The x-coordinate gives you the location. But remember, the x-coordinate is always the opposite sign because it's a transformation inside the function. And let's see, we're getting... Let's take a look at this one. It'll help you with some of the problem solving. And then I think, so that we're not just rushing through the rest, there's a little bit left. We'll do that on Wednesday's class. And I'll get on my way. So find the dimensions of a rectangular corral producing the greatest enclosed area given that 20 feet of fencing. So all we know is we've got 20 feet of fencing. We're going to make a rectangular shaped corral, and we want to maximize the area. So a rectangle has two characteristics, right? It's got a length and a width. How do we calculate the area of a rectangle?
Length times width.
Very good. Length times width. Could also use x and y if we wanted, but we'll do that. And then we're given this sort of constraint that there's 200 feet of fencing. What does that tell us? The perimeter. All of them combined are 200. So that tells us 200, and notice we have 2 lengths and 2 widths. So 2 times the length plus 2 times the width, which is the perimeter formula, equals 200. What that's going to allow us to do is get this, we're going to solve it for either L or W, and that will get us down to one variable in our area formula. Doesn't really matter which one. Maybe let's solve for L. So we subtract 2W from both sides. So we get 200 minus 2W equals 2L. And then we can divide each side by 2. And when we divide this side by 2, we'll divide each of the terms by 2. So we get 100 minus W equals L. We're then going to replace 100 minus W up here for L. So our area is equal to 100 minus W times W, and we're going to look to maximize that, so we distribute 100W minus W squared. Notice we have a quadratic. right? We just need to find the vertex of this quadratic, and then we will be good. The x coordinate, in this case, that's what we could think of W as our x coordinate, of that vertex is minus b over 2a. What is a? A is the number in front of the x squared, so that's going to be -1. 2 times -1. What is b? Well, that's the number in front of the x, which is 100. So we get minus 100. Negative and negative are positive. So we get 100 over 2. So the width is 50.
What's stopping you from just saying the width is 50 and the length is 25 and calling it a day there and splitting that up in your head?
You wouldn't necessarily know that that's the maximum, though. You could get various ones that would give you 200 feet, but to figure out that it's actually the maximum, we need to make sure that we're getting the vertex of the parabola. So then we know that this is 50.
So it's a square.
It's a square, and you'll
It's not, in fact, well, I guess squares are rectangles.
squares are rectangles. And you'll see this, that when you want to maximize area for a rectangle, a square will always do it. Now there's some questions in here where they'll say, oh, this side of the fencing, we want nicer fencing, so it costs more than this, and so those, you won't actually always, depending upon the constraints you get. But yes, in this case, we end up that the length was 50, the width is 50, it's actually a square. And I think there was 3 or 4 of these types of questions in the homework that we can work through, but you'll set them up this way. You need to remember perimeter formula and area formula, and they all end up giving you a quadratic. Find where that vertex is, and that will give you one of the values and then the other. But yes, you could also do a guess and check, but that also works. So let's go ahead and call this good for today. Work on some of the homework. Wednesday we'll come back, we'll finish up a few things, and we'll look at some of the examples from the homework.
Next Monday is the review, right?
And next Monday's the review. So I'll also introduce what to do for the review, which is in the system. Yes.
What lesson was this?
This is lesson 6. So we did 5 last Wednesday. We did 6 today. So these are our last 2 lessons for the midterm exam. Midterm is 1 through 6.
What day did you say midterm?
It'll be a week from Wednesday. So yeah. So next week, next Wednesday.